Rising temperatures. In this problem, we're given a table with the columns ID that has a type int, record date which has a type date, and temperature which has a type int. We need to write a solution to find all date ID with higher temperature compared to its previous dates. So in example 1, we have the table with the aforementioned columns. Now in this example, the days come one after another. So this is the 1st of January 2015. This is January 2nd, January 3rd, January 4th. If you notice, the temperatures for each day are 10, 25, 20, and 30 respectively. We need to compare the days that come after each other, see which one has a higher temperature, and return the ID of that date. So if we compare January 2nd to January 1st, we notice that January 2nd has a higher temperature, so we return ID 2, which corresponds to January 2nd. And the other example in this table is January 4 and January 3, where January 4 has a temperature of 30, while January 3 has a temperature of 20, and so we need to return ID 4, which corresponds to January 4. So the description and example are pretty self-explanatory. Let's go ahead and begin coding or writing the SQL. So the first thing we need to ask is what column from this table are we selecting to return? In this case, we're returning the IDs. And so we need to return, or we need to select from our weather table the ID column. So from our weather table. So if we really break down the problem on what we need to do, on every date that we're on, we need to compare the temperature of that date to the date previous to the date that comes before the one that we're currently on. And if that temperature is greater, then we need to return the ID of our current date. Now we need to ask, how do we do that in SQL? Especially if we're comparing values within the same table. And to address this, although it's true we have one table, what we can do and what we're going to do is we're going to do something in SQL called self-join. And that's when we join a table to itself. So before we continue, let's go ahead and do that. Since we're joining the table to itself, let's go ahead and call this weather table W1. And let's select the ID from W1. Now let's join the tables together. Inner join. We're going to use an inner join because we don't want to return null values, although in this example there won't be any null values. So since we're doing a self join, we're going to join it with the weather table, which is the first table and only table. And we'll call this copy W2. Now once again, before we continue any further, let's go ahead and actually see what the result is of combining the two tables together. Let's say, for example, we have this table with these dates and these respective temperature for each date. What SQL does once we join the tables, or in other words, what SQL does in these first 3 lines of code, is that it will combine every row from table W1 with every row from table W2. So row 1 from W1 is going to be combined with rows 1, 2, and 3 of W2. Row 2 of W1 will combine with rows 1, 2, and 3 of W2. And row 3 of W1 will be combined with row 1, 2, 3 of W2. So up until the join statement, we literally have the two tables sort of combined. Now in SQL, after you join tables together, you would join them on a certain condition. And this is no different here, but the condition that we need to use in this specific example is the same condition that's going to allow us to compare days that are basically one day apart from each other. So in SQL, there is a function called dateDiff, which is short for date difference. If you recall, when I was addressing what columns we have and their types earlier in the description, the record date column had a type date, and this date difference function actually takes as input the type date. Also, in SQL, dates are typically written in the form year, month, day. And now our date difference function, which calculates the difference between two dates, is going to take two different dates. For example, w1.recordDate, which is the record date of ID1 in our W1 table. And let's say it also takes w2.recordDate of ID1 in the W2 table. Now SQL is going to transform these two into something it can subtract, because remember, it expects type date, so it can convert the values given to it, whatever it needs to, in order to subtract them. And if you subtract this date from this date, you'll notice that there is a 0-day difference between the two because they're the same day. If we subtract this date from this date, we're gonna get well, it depends on what you put first in your date difference function. If you put W1 before W2, then you'll get a positive 1-day difference. But if it was the other way around, then you'd get a negative 1 day difference, and so on. So for example here, 1 and 4, you'd get either 3 or negative 3 depending on which order you put the record dates. And this is important to us because, like I said, in SQL, after you join two tables together, you're going to join them under a certain condition. And the condition that we're going to join them on is that date difference between two different dates, between w1.recordDate and w2.recordDate, should be equal to 1. What does that mean? We're going to join our w1 copy of our weather table to our w2 copy of our weather table on the condition that for every row in our combined table, which once again looks like this, w2.recordDate minus w1.recordDate should be equal to 1. So if we calculate the date difference of each row, we'll get these values. After we apply our condition, we're going to filter our table to only return results where date difference is equal to 1. So after we apply the date difference equals to 1 condition, our table conceptually is just going to contain these two green boxes. So let's go ahead and write that in SQL. So we're nearly done here. So we need to join them on the condition that date difference of w1.recordDate, and the D is capital, and w2.recordDate is equal to 1. Now in the example that I showed visually earlier, there is only one column where date difference is equal to 1. In other words, only 2 days are 1 day apart from each other. But in this example, we have 1, 2, and 3, 4. So we're going to get 2 rows where 2 dates are different from one another. In other words, we're going to compare January 4th to January 3, and we're going to compare January 2 to January 1. But one thing I want to address is that coincidentally in this example and the one I demonstrated on Paint, that when comparing the temperature of the current day that we're on to the previous one, this happened to be a positive difference. But we do need to account for possibilities where the current date has a temperature less than the previous day. So for example, if this temperature was 15. Now remember, they only want us to return dates or the IDs with dates that have higher temperature compared to its previous day. And so that's the final filter that we need to account for. And so we need to say where w1.temp is greater than w2.temp. If we go back to my demonstration, after we combine the tables, let's just look at the green boxes. We notice that W1 has a record date of October 2, while W2 has a record date of October 1, which means W1 comes after W2. And that's why we check if W1 has a greater temperature than W2. And actually, the column is temperature, not temp. So let me just fix that. So now let's submit and see if it works. Fantastic. So that was the rising temperature problem on LeetCode. I hope you found that video helpful, and thanks for watching.